name's Jay Ashworth, and I'm a first-year PhD student from the University of Tennessee. And today I wanted to tell you about a project that we've been working on in collaboration with the Flux team called Flux Fiction. So the problem that we're trying to solve in this project is an HPC job scheduling. So as the systems become more complex, the job of the scheduler also becomes more complex to be able to maximize the efficiency of jobs or the usage of the system. But what we've noticed is that on a lot of production systems, the scheduling algorithms themselves are pretty basic, despite the fact that there's a lot of research work that proves that there are ways that you could make it better. And the reason we think that is because most RJMSs, such as Slurm, aren't built to hot swap different scheduling algorithms, or they don't make it very easy to do so. And then on top of that, just actually being able to test out a research grade scheduler it takes a lot of time and has a lot of associated administrative burden. So Flux actually helps with the first of those issues, which is why Vanessa earlier mentioned that Flux is a good test bed for research, because it's really easy to swap out schedulers in Flux. But that still leaves us with the time issue, and so that's where we introduce Flux Fiction, which is a HPC system emulator that's designed to study scheduling within Flux by simulating two specific aspects: the user job submission and job execution. So we do this through a fully plugin based approach, which kind of combines the best of both worlds from other HPC scheduling simulators by allowing you to have the trustworthiness of plugging into a real RJMS, in this case Flux, but also having the flexibility of a lot of different fully simulated solutions. And so we actually use our two plugins here, one to simulate job execution and one to kind of get a feel of what's going on inside of Flux. And we integrate these directly into the job lifecycle of Flux. And so with our tool, there's a couple of different results that I wanted to show you just to kind of demonstrate the capability here. So the first one of these is a small scale analysis where we used 100 synthetic jobs on a 100 node system and wanted to show the difference between first come first serve and conservative backfilling, so swapping out different queuing policies. And if you know about scheduling, this has a pretty obvious result. We get a lot more utilization once we introduce backfilling. But the important thing here is that using Flux Fiction, we were able to get these results in a matter of seconds versus if you ran it on a real system, it could have taken hours. And then we've also scaled up the number of jobs that we ran on Flux Fiction just to see if it could handle it. And so in this experiment, we did 100,000 jobs, which is about 2 months worth from the Lassen supercomputer, a 792 node system that was recently decommissioned at Livermore. And we were able to run that in about 9 hours, which resulted in a 211 times speed up over what the real world would have been. And so with that said, what we're looking to do next with this tool is kind of more what-if scenarios. So one specific technical aspect that I'm excited about is to be able to plug in application performance modeling. And then as far as research avenues, we're interested in exploring storage subsystem scheduling as well as elastic and malleable scheduling. All right. That's everything I have today. If you have any questions, I will be around. I don't think we have time.